Hello, welcome back once again. In our today's video, we're going to solve this United States Olympiad mathematics problem. So we're given an equation involving squares, cubes, and factorials of n, and we're going to solve for the integral value for n. We have n cubed is equal to 2 times n factorial plus n squared. Let us note the following. When we talk about the factorial, we mean n multiplied by n minus 1, multiplied by n minus 2, multiply all the way to 3 times 2 times 1. So this implies that 5 factorial will be equal to 5 multiplied by 5 minus 1 is 4, multiplied by 4 minus 1 is 3. We can see we have 2, then we have 1, and this will give us 120. So this is what this factorial is all about. Now let's solve this problem. From the left hand side, we have n to the power of 3. Let's subtract n squared from both sides. So we have minus n squared. This is equal to 2 multiplied by n factorial. From here, we can see that n squared is common. Factor it out, so we get n squared. Into bracket, we just have n minus 1. This is equal to 2 multiplied by n factorial is same as n multiplied by n minus 1 multiplied by n minus 2 factorial. Okay, so from here, n squared is same as n multiplied by n. Then we have multiplied by n minus 1. This will be equal to 2 multiplied by n into bracket n minus 1 into bracket n minus 2 factorial. Obviously, sorry for that, 0 is not a solution, right? Because 0 cubed is 0, but the right hand side is not 0. The only problem here is the n factorial, and we know that 0 factorial is equal to 1. So if n is equal to 0, we have 0 is equal to 2, which is not true. So n is not equal to 0. And n can only be greater than 0, right? But must be an integer, since we're solving for integer. Remember, the factorial is not defined for negative numbers, right? Okay, so not only the case if n is equal to 0, we also have to check out if n will be equal to 1, right? Now, 1 cubed is 1, and here we get 2 times 1, which is 2, plus 1, which is 3. We have 1 is equal to 3, which is not true. So we're going to cancel n from both sides, and also cancel n minus 1 from both sides, since n cannot be equal to 0 and cannot also be equal to 1. So from here, the only thing left at the left hand side is just n. This is equal to 2 into bracket n minus 2 factorial. Let's divide both sides by n minus 2 factorial. So this will cancel this from here. So therefore, from here we get n divided by n minus 2 factorial, which is equal to 2. Okay, now take note. If n is greater than 4, then the left hand side n divided by n minus 2 factorial will be less than 2, because the bottom will be larger than the numerator. Okay, let us take the integer 5. So if n is equal to 5, we get 5 divided by 5 minus 2 factorial. 5 minus 2 is 3. 3 factorial is 6. So 5 divided by 6 is obviously less than 2. If n is equal to 6, we get 6 divided by 6 minus 2 factorial, which is 6 over 4 factorial. And we know 4 factorial is equal to 24. We get 6 divided by 24, which is equal to 1 all over 4, or 0.25. And that is also obviously less than 2. So we can see that n cannot be greater than 4. Remember, we are interested in integer solution, right? Okay, so since n is not since n cannot be greater than 4, so the only thing we have to check out here is when n is equal to 2, when n is equal to 3, and when n is equal to 4. Remember, we have this, that n cannot be equal to 0 and cannot also be equal to 1. Now let's check out 2. If n is equal to 2, therefore we get 2 divided by, so here we get 2 minus 2, which is 0, so 0 factorial, which is equal to 2 divided by 0 factorial is 1, which is equal to 2. So this is valid. If n is equal to 3, then we get 3 divided by 3 minus 2 factorial, which is 1 factorial. So 3 divided by 1 is not equal to 2, so n is not equal to 3. Now, if n is equal to 4, so we get 4 divided by 4 minus 2 is 2, which is 2 factorial, which is equal to 4 divided by 2, which is equal to 2, which is also valid. So therefore, we have the only two integer solutions to the problem. We have n is equal to 2, we have n is equal to 4. So here we have our solution. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.